This is Algebra 1, Lesson 5C, the addition of signed numbers, and it includes examples 5.2 through 5.6. We start this part of the lesson with an expression. How would you read this expression? And what does that mean? Well, most of you would probably say 3 minus 2. And I would agree with you. Some people may say 2 less than 3. Or maybe 3 diminished by 2. You could get fancy a little bit. Right? So there's several different ways to think about it, but probably most of us think of it this way. And we would say the answer is 1, right? But after you've been doing some positive and negative numbers, you may be like, well, how am I supposed to know if this symbol is a minus or if it's a negative? Well, in algebra, we treat it a lot of the time like it's a negative, even in this situation. So we said it's 3 minus 2, but some people may say, well, is that 3 negative 2? 3 negative 2? We're going to talk about something in this video called algebraic addition. Okay, and a lot of times I will tell my students this. Subtraction is the same as adding the opposite. Okay, subtraction is the same as adding the opposite. That means for this problem, I could rewrite it as 3, but instead of subtract 2, I could say adding a negative 2. Because what's the opposite of positive 2? Negative 2. So 3 minus 2 is exactly the same as 3 plus a negative 2. And in algebra, it's often beneficial for us to think about subtractions as adding a negative, or adding the opposite of the second number. So we're going to look at a number line. We have negatives to the left, positives to the right, 0 in the middle. We can slide that and start it anywhere we want to start it. And we could do that same problem here. So what I'm going to do is we always start at the origin. Okay, so that's key. Start at the origin. And the origin is 0, right? So we're going to start over here at 0. And what we're going to do, your book shows it does like a little dotted line. Okay, I'm going to go up to my next notebook line or so. And I'm going to go the first number. Okay, so I'm going to go 3, which would mean if I'm going positive, I've got to go in the right direction. So I'm going to go 3 and stop right there. Okay, they draw an arrow saying they got to that point, and then they stopped, and then they draw another dotted line, and then we say we're going to go negative 2. We're going to go back 2. So we're going to go back 1 and back 2 and bring our dotted line down. So this was the plus 3, and this was the minus 2, or the negative 2. Now where do we end up? Come straight down from where we end up, and that's our answer. We end up at 1. And we knew that 3 minus 2 is 1. So it's going to feel like they're trying to overcomplicate things a little bit. I understand. But it's just a different way of looking at a subtraction. And it will help you when we get further in our study of algebra. So let's try another one. Let's add positive 3 and negative 5. Now this could also be written as 3 minus 5. Okay, so you may know how to do that already, and that's great. But let's look at it on the number line. We're always going to start at the origin. We're going to go to the right 3. Then we're going to, that took care of this. Then we're going to go to the left 5. So we go over, let's say I got to count 1, 2, 3, 4, 5. It's going to end up right here. Okay, so we went to the right 3, we went to the left 5, and we ended up at negative 2. So that answer equals negative 2. It's really helpful to use a number line with these so that you know what sign you end up with. And you don't always have to draw it. Once you get used to this way of thinking, you'll be able to think of a number line, or maybe even do it without that. But for the homework, they're going to ask you to draw number lines. Example 5-3. Very similar problem, but they're switching the order around. So this would be like -5 plus 3. Again, I start at the origin, okay, and they drew dotted lines, so I'll do a dotted line. And then we go back to the left 5, and I needed to write in a -5 here because that's where it's going to take us. We're going to go down to the -5, okay, and then we're going to go, let's see, that's -5, and then we do our little dotted line here. We're going to go to the right 3. So 1, 2, 3. This is a +3. And where do we end up? We end up at -2. So -5 plus +3 ends up at -2. So you can see, even if we switch the order, we did the +3 first and then the -5, we ended up at -2. If we do the -5 first and then the +3, we end up at -2. And we get the same answer either way. That's helpful to know that. All right, example 5-4. Add +2 and +1. So this is just +2 plus 1. We know that answer. But let's see if we can draw it. We always start at the origin. We're going to go in the positive direction 2. And then from there, we're going to go positive direction 1 more. And we're going to end up at 3. So our answer is 3. Example 5-5. Add -2 and -1. So it's just -2 plus -1. Now, often when you see a plus a negative like that, they will put the negative in parentheses. This is not meaning multiplication because we see we have this addition sign there. Okay, so that addition sign is saying I'm adding this number plus this number. Okay, so we're going to start at the origin and we're going to go -2 and then pick up from there and go back 1 more, and you'll see that you end up at -3. Example 5-6. Oh wow, we're getting longer here. We're still going to start at the origin. We're going to go to the left 4. And then we're going to go +2. So 2 to the right. And then left 1, negative direction 1. And then positive direction 5. So there's 1, 2, 3, 4, 5. Positive direction 5. And I end up at the number 2. This is equal to 2. And that 2 is a positive. Now remember, if we do not put a symbol in front of the 2, that means it is positive. And that is our final answer. Could you do it another way by changing the order? Yes, we determined in this last example here, or the first 2 examples, that the order didn't matter, because if you're adding, you can change it, like 3 plus 2 is 5 and 2 plus 3 is 5, right? You can't change the order of subtraction and get the same answer, but you can change the order of addition and get the same answer. So that's helpful. You could have done in any order you want, and the book actually does it in a different order, and then you will see that it's the same.